Alright guys, welcome to today's review from what we worked on in class today. Remember, we're going to look at solving linear equations that have one solution, no solution, and infinite solutions. So what I've drawn up here real quick is kind of easy, simple problems for us to look at to kind of give you the basic idea of what we're looking for. Okay, remember, type 1 case is one solution. This is an example of problems that you guys have really seen a lot of. We've all done these. You're looking for an answer that I can plug in for x that will make this left side equal the right side. Okay, and in this case, there's only one number that I'm going to be able to plug in for this one. And remember, if we solve this, all I'm going to do is divide this by 3. This is going to give me x equals 4. Now what that means is 4 is the only number I can plug in to multiply times 3 that would make 12 equal 12. Okay, this is something that you guys are used to seeing. We've been working on these for a while now. So we have gotten pretty good at those, but now these new ones are the ones that we need to kind of take a look at because they are a little different and they do look a little weird from what we're used to seeing because we're not used to solving problems that don't have a solution. Okay, but in some cases you will. So this is just a basic problem here. If I look at this one, what I'm looking for is there a number that I can plug in for x here and x here that will make the left side equal the right side. Well, it doesn't really matter what number I plug in for x. If I add 5 to it, it will never equal x on this side. So if I plug in a 1, so if I plug in a 1 here, okay, and a 1 here, if I add 5 plus 1, 6 will never equal 1. So that's what you're going to have. Something here that's a no solution is actually always going to work out to be a false statement. Okay, it's not going to be true. There's not a number that I can plug in to make that true. Now, infinite solutions on the other hand, remember your left side is going to look exactly like your right side. If I plug in a 1 here for y, and I plug in a 1y here for y, 1 is going to equal 1. If I plug in a 0, 0 equals 0. If I plug in 10 million here, 10 million here, your left side is always going to equal your right side. Okay, so that's the way we look at these problems. If I, like I said, if I plugged in 3 for y and 3 for y, 3 equals 3, these will always be true statements. Okay, so that's what we're looking at. So the difference here is what you're normally used to seeing compared to what we're learning now is recognizing when is it going to be false and when is it going to be true. Okay, let's look at how these will work out. Let's see how we can solve these. So let's take this away. We've already done this one. Let's rewrite that back. So if we divide by 3, again, x is going to give me 4. So if I want to solve this one, okay, remember our steps. Let's move this x from here to here. And what goes happen here, this goes away. I have 5 equals, now x minus x is 0. Remember, it's not 0x, it's just 0. So in this case, 5 will never equal 0. So this is a false statement. Also notice, if you will, the variables are gone. The variables actually really would cancel themselves out. So I have no variables. The variables drop away. False statement. Okay. So let's look over at infinite solutions. So if I was to move this y from one side of the equation to the other, this one's going to cancel. This one's going to cancel. I have 0 equals 0. Now 0 equals 0 is a true statement. So that means these numbers, anything I plug in on this side will equal this side. So notice again here, the variables dropped out again. They're gone. And I'm left with just a constant equals a constant. Okay. So here your variables will go away. Your variables will go away. Here you have a variable remaining. Okay. So let's look at a few problems. I think I got 2 or 3 of each type. Let's see what we got for these. Okay. All right, first one, let's go back to what we worked on in class. Remember, if we like to put our boxes around our variables, so box, circles go around constants or numbers, okay? So now rule 2 on our rule says to combine like terms, so 5m plus 3m is 8m plus 7 equals 23. All right, so now we can combine again. Let's go box, circle, circle. All right, so if we're looking at this, so now I have a box and I need to move this around. So let's move this 7 away from that variable. Let's get our variables on one side, our numbers on the other. This is going to go away, so 8m is going to equal 16. And then the last step, we divide by 8, m gives me 2. So one solution when m equals 2. Okay, so just combine and move. Alright, let's look at one over here. Let's see what we've got on this side. Now, let's kind of the same concept, but now if you'll notice my variables are separated. So let's do the same thing. Box, box, circle, circle. So now I'm still doing the same concept. I'm still going to combine this. This says 6x plus 2x will give me 8x. Then I didn't do anything to the 4, so bring it down. So we have box, circle, circle. This variable is isolated on the left side, so let's move our numbers to the right side. This is going to be a 0 pair. It goes away, so I have 8x equals 24. Divide both sides by the number in front of the variable. In this case, it's 8. So I have x equals 24 divided by 8 is 3. So one solution when x equals 3. Okay, let's go over here and let's try to find this one over here somewhere. I got to find it right here. Here it is. Should be right here. All right. Now we got variables on both sides of the equations and we have parentheses. So we got a little work to do with this one. So let's start by clearing this parentheses out with distributive property. 5 times 2 is 10. 5 times a negative 3x is a negative 15x plus 15 equals negative 6x minus 11. All right, now that I have the parentheses cleared, now I can put my boxes and my circles. Circle, boxes around variables, circles, box, and a circle. Okay, all right. Now we can do a little combining. I don't do anything here. I tend to kind of like to write my variables first. It doesn't really matter as long as you keep your signs the same. So I have a combine this circle with this circle. So 10 plus 15 gives me 25. And then we can work over here. We haven't done anything to this side yet. We're about to. Okay, so box, circle, box, circle. Now if you'll notice, I can't do any more combining, so now I need to separate my variables from my constants. What I like to do, remember we talked about this in class, I like to deal with positive variables if I can, so I'm going to move my small variable. Remember, even though 15 is bigger than 6, we're talking negative numbers, so I'm going to take, and that makes this one the smaller number. So I'm going to add 15 to both sides. Excuse me, 15x. I do apologize. Remember, you got to take the x with you. Okay. This is going to go away. Let me move this up just a little bit. Okay. Bring down the 25. Okay. Now, negative 6 plus 15, that's going to give me a positive 9x minus 11. All right. So circle, box, circle. All right. Let's extend our river. Now, this time I need to move this number. Since I brought my variables to the right, I'm going to move my numbers to the left. Goes away. I have 9x equals 36. Divide by 9. X is going to equal 4. So 4 is the only number I can plug in here and here that makes the left side equal to that side. So even though it's a long problem, it's a lot of work to get to here. But if you can do this problem, you guys are going to be pretty good on everything else. All right. Okay, let's look at this one. Now my parentheses are on the right side, but guess what? It's the same thing. You're still going to clear using distributive property. Okay, so negative 2x plus 30 equals 30 minus 36x. All right, so now the parentheses are gone. So box, circle, circle, box. All right, so now we can do a little combining. Now again here, negative 36, that number is smaller than negative 2, so I'm going to move that one to the right side. I'm sorry, to the left side, excuse me. This is going to go away. I'm going to have 30. Bring down this 30. Now negative 2 plus 36 gives me 34x. Okay? Remember your integer rules. Signs are different. Subtract from the bigger number and keep the bigger sign. Alright? So now we have box, circle, circle. let's move this 30 over here since all of my variables are on the left side. Let's move this 30 over here. This is going to cancel, so I have 34x. Now, 30 minus 30 is 0. All right. Now, this is where you got to be very careful right here, because a lot of you may see that 0 and you may say, wait a minute, this is going to be a no solution. But remember, the last thing I have to do for all these problems is if there is a number in front of my variable, I need to divide by that number. Okay? So this cancels. Now, if you put this in your calculator, 0 divided by anything is 0. Remember, we talked about this in class. This is actually an answer. This is not no solution. This is x equals 0, which means the only number I can put in for this x and this x to make the left side and the right side equal is 0. So this one is one solution when x equals 0. Okay, so those are some pretty tough problems. If you can do those, you're right on time. Okay, all right, let's see what we got on this one. Okay, first thing I notice, I'm going to draw my river. Second thing I notice is I have some parentheses I need to clear. Okay, so I have 20 minus 3m equals negative 3 times m is negative 3m. Negative 3 times negative 4 is a positive 12. Now remember, we talked about this in class today. Some of you may remember this really quick. You see right here real quick, this negative 3 and that negative 3 will cancel. That's going to go away, so I'm left with 20 equals 12. Okay, right now we know this is false, so right now I know this is a no solution problem. But I'm going to go ahead and finish this out. I'm going to subtract 12. So I have 0 equals 8. And remember, if it's false here, it's going to be false here. So this one is still, again, a no solution problem. Okay? So remember, and again, if you needed to move these around, this would cancel out to be 0. But since they are the same exponents, the same variable, they will cross each other out. Okay? Let's look at this one, if I can find it. Okay? All right? Let's do this one. First off, again, I like to clear these parentheses first. Negative 3 times negative 2 is a positive 6a. Negative 3 times a negative 8 is a positive 24. Okay? And then on the right side, I have 6a plus 22. Well, that's a terrible 22. Let's fix that. And if I notice these problems, 6a and 6a, well, immediately that jumps out. Those guys are going to cancel. I'm left with 24 equals 22, which again, that's a false statement. So right now I know this is no solution, but I'm still going to finish this out. Let's go ahead and work it on down. 22 minus 22 is 0, and 24 minus 22 is 2. So 0 and 2 do not equal each other, so this one is a no solution problem. Okay? All right, this last one, let's see if we can find it right here. Okay? Draw your river. Distributed property on the back side after I have to add 7 to it. But let's get rid of this property first. Okay? So let's move this up just a little. Maybe we can move it up. All right. So I have 13 plus 4a equals 7 plus 4 times a is 4a plus 12. All right. Got a little work to do. We're not finished on this side yet because we have a circle and we have a circle. So we have to finish this out. 13 plus 4a equals 7 plus 12 is 19 plus 4a. All right. Look what I see here. This variable has the same number on both sides. So 13 equals 19. And if I want to finish this out, 0 equals 6. Remember, if it's false here, it's going to be false here. But we like to work it on down as far as we can get it before we finish. So this one also is a no solution problem. Okay? How do you feel about this so far? I think you guys are really doing well on these today as far as on the whiteboards. So we're going to do a little more tomorrow, but I want to kind of work you out a few of these problems. All right, let's go here. All right, first thing, let's try. Now these I'm going to try to work out should be all infinite solutions, but let's see. First off, let's clear parentheses first. Oh, we have double parentheses, don't we? So we got to do it both ways. So we have negative 8x minus 20 equals 2 times negative 4 is negative 8x. 2 times 10, negative 10 is negative 20. Wow, what do I see here? This side is equal to this side, so right now I know this is a true statement. So I know it's going to be infinite solutions, but let's do what we did. Variables are the same, cross them out. Constant are the same, cross them out. 0 is equal to 0. And again, if it's infinite here, if it's true, it's going to be true here. So we have a true statement there. Okay. Let's see what we have here for problem 2. Okay, let's look at this one. I know I'm going kind of fast, so remember, if you need to back it up and slow it down, back it up and regroup. And I would like for you to try a lot of these problems on your own and pause the video and start it back up after you've tried to solve them. Okay, all right, let's do distributive property here. So we've got to clear this parentheses first. So negative 6 times negative 6 is a positive 36. Now, if you need to put the 1 here, you can. Nothing wrong with that. Okay, so I have negative 6 times negative 1p is going to give me a positive 6p. All right. So the left side's done. Look at the right side. Wait a minute. I see parentheses, but my multiplier is on the back side. Guys, that doesn't matter. It's still distributive property. Okay. So 18 times 2 gives me 36. 3 times 2, 3p times 2 gives me 6p. Well, if you look, these equations are the same. 36 plus 6p equals 36 plus 6p. So I know right now this is a true statement, so it's going to be infinite. But hey, remember, cross out. These are going to cancel each other. 0 is going to equal 0. All right. Nice job with these so far. I think you guys have gotten the hang of these. But let's see what we can do with this one. All right. Draw our river. Uh-oh. Well, if I look here, this tells me one of two things. I can do one of two things here. This negative on the outside of a parentheses tells me to take the opposite of whatever's on the inside of the parentheses, or I can do this. I can put a 1 in front and then distribute. So the choice is yours, whichever one you feel comfortable doing. Either take the opposite or multiply by negative 1. So negative 1 times x is going to be negative x. Negative 1 times negative 6 is a positive 6. And on the right side, 6 minus x. Well, even though they're written differently, 6 is still going to cross out 6. Negative x is still going to cross out negative x. And I have 0 equals 0. Okay? True here, true here. All right? That was kind of complicated because just for the simple fact, you have to remember that's a negative 1 or to take the opposite sign. Okay? Let's look down here. Uh-oh, this is a pretty good size problem here. And I see some things you guys really seem to want to shy away from, but guys, fractions are not going to hurt you. They've done just like everything else, except you have to use your calculator, or sometimes you have to be able to do it by hand. But we can do this. Let's do this left side first. I'm not going to shy away from it. Here we go. Let's distribute here, and let's distribute here. Now, what this is saying is 1/2 of 18x. So what is 1/2 of 18? That's 9. What is 1/2 of 16? That's 8. And then you're going to take the rest of the problem and do it the same way. Distribute. Okay. So you have 4 times 3x is 12x. 4 times 2 is 8. And then minus 6x. Now let's finish it out. So I have a box. And I know I haven't been doing boxes and circles, but on this one I'm going to. Circle. Box. Box. Circle. Box. Okay. Now let's combine the left side. 9x minus 3x is 6x plus 8. And then on the right side, 12x minus 6x is 6x plus 8. Okay, so now this 6x is positive, this 6x is positive, so they will cancel. Plus 8 will cancel plus 8, so 0 is equal to 0. So if it's true here, it's going to be infinite. That means it's going to be true here. So we have infinite solution on these problems. Okay, so just as a quick recap, remember, let's go back to the very first page. Remember, one solution, x equals a number. No solutions, you're going to have a number that does not equal a number. The two numbers will be different. And then infinite solutions, your numbers will be the same. In this case, it's going to be 0 because 0. You remember, you can have other stuff too, as long as your left side is equal to the right side. No solutions will always be false. Infinite solutions will always be true. All right, guys, have a great evening. I will see you tomorrow.